Good day, everyone. Today's topic is all about angles. Angles is one of the basic concepts in geometry. In geometry, a ray can be defined as a part of a line that has a fixed starting point but no end point. It can extend infinitely in one direction. So these are the examples of a ray. So as you can see here, we have a point that is the fixed starting point, the point A, and the point B, and we have the arrow at the end of this straight line. So as you can see, this fixed starting point, while this arrow, it implies that it will extend infinitely in this direction. So this ray is named as ray AB, or it can be denoted by the symbol, a small ray symbol at the overhead of 2 points AB, and it will be read as ray AB. We have also an example here. The starting fixed point is point E, and the arrow is pointing at this direction. So it will be named as ray TU, or with this denotation, ray TU. Another one, we have also point Y as the starting fixed point. Will be to the left downward. So it is named as ray XY, or with this denotation, ray XY. And the other one, we have the starting point is the point K, and it is the arrow is pointing upward, so it will go upward infinitely in that direction. So it is named as ray KM, or with this denotation. So the concept of this ray is used in forming an angle, as it is defined angle when two rays meet at a point, they form an angle. And the point of intersection is called vertex. So we have two examples here. CA and the ray CT. So the two rays meet together at one point, that is point C. And this point C is their common starting fixed point. So as you can see, these two rays, ray CA and the ray CT, form an angle. And the point of their intersection, which is the point C, is called the vertex. So this angle can be named as angle ACT, or with this symbol, angle ACT, or angle TCA, or with this symbol, and angle C, or with this symbol. So as you have observed here, the point C is always placed in the middle when naming the angle, or it can be also be named only with C as angle C. So we have also here the ray IM and the ray IG, where these two rays meet together at point I, and it is their fixed intersection point, the starting point. And it can be named as angle MIG, or with this denotation, angle GIM, or with this denotation, or just angle I, or with this denotation. So as what you have observed again, I is always placed in the middle, or it can be named only as angle I. So let's continue with the types of angles based on their measurement. So we have number 1, acute angle. What does it mean when we say acute angle? It is defined as acute angle is an angle that measures less than 90 degrees. It is smaller than right angle. So when we said it is less than 90 degrees, so the angle measurement ranges from 1 degree to 89 degrees. So just like for this example, we have the point R, the point A, and the point Z, or the ray AR and the ray AZ, having the measurement of an angle which is 49 degrees. So the angle formed here, or the measurement RAZ, belongs to the type acute angle. Okay, let's proceed for number 2 type. So for number 2 type, we have the right angle. What does it mean when we say right angle? Right angle is an angle which measures exactly 90 degrees. 90 degrees. So when we said right angle, there is only one exact measurement when we said right angle, and that is only 90 degrees. So just like for this example, we have angle CFK or KFC. And the measurement of the angle is 90 degrees. As you can see, the denotation or the symbol here, the green curved line, this line forming a square denotes a measurement which is 90 degrees. So let's proceed for type number 3. And the type number 3 is what we call as obtuse angle. So what does it mean when we say obtuse angle? So obtuse angle is an angle that measures more than 90 degrees but less than 180 degrees. What does it mean? So it means that the measurement of obtuse angle ranges from 91 degrees to 179 degrees. So the measurement 91 to the interval 91 degrees to 179 degrees. Let's see for the example. We have here angle BPU or angle UPB. So as you can see, the measurement of this angle is 109 degrees. And 109 degrees belongs to the interval between 91 to 179 degrees. So therefore, this angle with the measurement 109 degrees belongs to obtuse angle. And for the last type, we have also the straight angle. The number 4 is a straight angle. What does it mean when we say straight angle? So it is defined as straight angle is an angle which measures exactly 100. So just like the right angle, which has an exact measurement of 90 degrees, also the straight angle has only one measurement that is exactly 180 degrees. So as you can see here, we have angle PBU or UBP. Then the blue curve line here represents the straight angle that measures 180 degrees. So whatever the position of these two rays in opposite direction with a common starting point, point B, it can be in slanting position, it can be in slanting to the left position, then it forms 180 degrees, then it belongs to straight angle. And now, for your exercise, identify the types of angle of the following measurements. So we have here number 1, number 2, number 3, and number 4. So for number 1, we have the angle measurement which is 56 degrees. Number 2, we have 90 degrees. Number 3, 97 degrees. And number 4, 167 degrees. So I think that's all for today. So thank you for listening and may God bless you all. Good day, everyone. Today's topic is all about algebraic expressions. Objectives: to give the meaning of a variable in an algebraic expression. 2. To translate verbal expressions into letters or symbols and vice versa. 3. To represent quantities in real-life situations using algebraic expressions. Definitions. Numerical expression is an expression that combines numbers and one or more operation symbols. Examples: 27 plus 7. 525 minus 34 times 12. Variable. It is any letter or symbol that represents a number. Examples: A, B, C, D, E, and so on. We have also these symbols. Next is constant. Constant has a fixed value that not change. Examples: we have 7, 15, negative 5, 109, and so on and so forth. Now let's proceed to algebraic expression definition. Algebraic expression is a mathematical phrase that uses variables, numerals, and operations m plus 12, 7 minus x, and 6w. Now let's proceed. Translating word phrases into algebraic expressions. So to translate word phrases into algebraic expressions, familiarity with words and phrases associated with symbols or operations are important. Let's look the table below. List of some keywords that are used to describe common mathematical operations. So we have here the symbols and the keywords or the phrases. So for addition, the keywords will be addition plus the sum of, increase by, total of. That would be for addition symbol. And for subtraction symbol, we have the keywords and phrases subtraction, minus, the difference of, less than, decrease by, diminish by, subtracted from, or less. That would be for subtraction symbol. And for the symbol for multiplication, we have these three symbols. So the keywords and phrases will be multiplication times the product of twice multiplied by or of. That would be for multiplication symbol. Also, we have for the division symbols. As you can see, these three to represent division. So for the words and phrases, we have division, divided by, the quotient of, or the ratio of. That would be for the division symbols. And for the equal symbol, as you can see, this is the equal symbol. The keywords or the phrases that is being used will be, or are, is equal to, equals, is the same as. So these are the keywords being used for the symbols in these operations and equal sign. Now let's study the tables below. So we have here the word phrases and algebraic expression. So for the word phrases, this as on. So this algebraic expression can be expressed in word phrases in 5 times or more. So we have m plus 3. In algebraic expression will be m plus 3. The sum of m and 3, m increased by 3, 3 added to m, and 3 more than m. These word phrases will be expressed in algebraic expression in an only this way. That is m plus 3. Okay, next. We have the word phrases n minus 11. The difference of n and 11. N diminished by 11. 11 less than n. N less 11. And also 11 subtracted from n. So the algebraic expression for these word phrases is, as you can see on the screen, that is n minus 11. Let's proceed. The word phrases and algebraic expression. So we have 2 times w, twice of w. We have also w multiplied by 2, the double of w, and product of 2 and w. So for the algebraic expression, it would be 2w. Next, phrases and algebraic expression. So we have x divided by 5, 1/5 of x, the quotient of x, and 5, the ratio of x to 5. So these 4 word phrases can be expressed only in one algebraic expression, x over 5 or x fifth. And now let's proceed to the examples. We have here example number 1. Translate the algebraic expression 7 more than twice a number. So we let x be the number. Then it must be written as 2x plus 7. That would be 7 more than twice a number. So as you can see, twice a number, that is 2x. That is why the operation is addition. And 7. So that is why the answer for algebraic expression for this word phrase is 2x plus 7. Or 7 more than twice a number. Example number 2. Translate to algebraic expression the sum of a number and 9 divided by 4. Once again, the sum of a number and 9 divided by 4. So we let m be the number, then the sum of a number and 9. So we let m be the number, so it must be written as m. Represents the number. Then the word the sum, it refers to addition. That is why the operation is addition. 9. Then, we translate divided by 4. So, the word divided by refers to division. So, that is why we have here the division symbol. And 4, that is 4. Therefore, the algebraic expression for the word phrase, the sum of a number and 9 divided by 4 would be m plus 9 over 4. Or m plus 9 divided by 4. And now for your exercise. We have here, determine the constants and the variables in each algebraic expression. So we have the column for the algebraic expressions. Then you are going to write here in this column the constants, and in this column in each of the algebraic expression here. So we have 3a, x plus 7, negative 3d, n over 3, and h minus 5. That would be for letter A. And for the exercise letter B, we have or you have to translate the following word phrases into algebraic expressions. So we have also 5 word phrases here, and on this column, you are going to write the algebraic expressions. So we have number 1, 4 more than y. For number 2, 15 added to f. Number 3, 6 subtracted from q. Number 4, r increased by 11. And number 5, thrice k. Good day, everyone. Today's topic is all about describing and illustrating parallel, perpendicular, and intersecting lines. What is a line? In geometry, a line can be defined as a straight one that has no thickness and extends endlessly in both directions. It is often described as the shortest distance between any 2 points. Line can be named by the uppercase letter like A, B, C, and so on. And also a lowercase letter. So we have here examples. We have line AB and can be named as line AB or line BA, or in symbol, simply with a small denotation or symbol line in the above of the 2 letter points, we have AB or as line AB. Also, it can be named with a small or lowercase letter, just like. So we have here line M. So it can be written line M or with this symbol, line M. And another one, we have also the line KP. So as you can see, we have the symbol is line KP or line KP or just line PK. So it can be written as in both directions. It could be AB or BA. It could be KP or PK. So we have also the types of lines. First, we have the parallel lines. Parallel lines are lines that have equal distance between them at any point. They will never meet no matter how far it is extended. So as you can see here, we have JK and the line LM. So these two lines having a equal distance from this direction and to this direction. So it means that when this arrowhead and also this arrowhead extend to the left direction, and also with these arrowheads and to the right direction, still the distance of the two lines are equal, and these two lines will never meet no matter how far or how farthest it is extended. So in symbol, it can be written as with this, line JK is parallel to line LM. So we have another example with these two lines, the line TX. Line is line X. So line T is parallel to line X. Involving integers. To perform expression with more than just Good day, everyone. Today's topic is all about order of operations. Order of operations involving integers. To perform expression with more than just one operation, we must follow the so-called PEMDAS rule. What does it mean when we said PEMDAS rule? PEMDAS are the acronym for its rule. So we have the P, E, and S. And it's called PEMDAS. So we have first the P and E. P is for parenthesis. E is for exponent. P and E are paired. This pair of operation must be executed first from left to right in any order. We have also the second one, or the second pair is the M and D, where M is for multiplication and D is for division. So this pair of operation must be executed next to the pair P and E. It's also from left to right in any order. And the last pair is the A and S. And S is for subtraction. So this pair of operation must be executed next to M and D from left to right in any order. So based on the explanation of these pairs, as we can see here, there's these words from left to right in any order. From left to right in any order, and on the last pair, from left to right in any order. So what does it imply? So it implies that when these two operations, which is the P and E, and the second pair, M and D, and A and S for the third pair, when we said from left to right in any order, first with E, or in any order when E comes first from P, so it must be executed first. Just like this M and D. When multiplication comes first from division, then multiplication must be executed first from left to right, and vice versa. If division comes first, then division must be executed first before multiplication. Same with addition and subtraction, or the AS pair. When subtraction comes first, then subtraction must be executed first before addition. Next, we have example number 1. So applying, we are going to simplify this expression below. So we have the expression 10 raised to the power of 2, or 10 squared, plus 13 times 3 minus open bracket 15 plus open parenthesis negative 9 close parenthesis close bracket divided by 6. So when we apply the PEMDAS rule in this expression, we need to execute first the pair which is P and E, or the parenthesis and exponent. So in this expression, we can see that 10 raised to the power of 2 is one of the terms that has an exponent. And also, we have 15 plus negative. So these two must be executed first. Then from the two, exponent and parentheses, from the left side, we can see that exponent comes first before the parenthesis. So we must execute first the exponent, then followed by the parenthesis and bracket. So in the solution, we have 10 squared, which is equals to 10 times 10. It will give us 100. Then copy the remaining or the addition operation. Copy as it is the 13, the multiplication operation, the 3, the subtraction operation, then execute this one. It will give us 15 plus negative 9. It will give us positive 6. Then copy as it is the 6. Then it will give us 100 plus 13 times 3 minus 6 divided by 6. So first pair, or the first pair in the PEMDAS rule has been executed. So let's proceed to the second pair, which is the M. The perimeter of a polygon is equal to the sum of the length or the length of all its sides. Perimeter is the distance around a plane figure. First, we have the perimeter of a triangle. The perimeter of a triangle has a formula of P is equals to S sub 1 or sine 1, S sub 2 plus S sub 3. where P stands as perimeter, and S sub 1 as side 1, S sub 2 as side 2, and S sub 3 as side 3. Let's take for this example. We have this triangle. As you can see, the measurement of this side is 8 centimeters. Side opposite is P is equals to S sub 1, S sub 2, plus S sub 3. So we let this 8 centimeter S sub 1 or the side 1. And this 9 centimeter or the base side as S sub 2. And the 10 centimeter or this side is the S sub 3. So we have 8 centimeter plus 9 centimeter plus 10 centimeter, and the total it is equal to P is equal to 27 centimeters.